So in this video, we're going to talk about Fischer Transesterification, and I'm also going to talk about the hydrolysis of them also with the mechanism. Okay, so the idea is that if I take a simple ester and an alcohol, yeah, and I add this in heat and acid, okay, I'll get the ester. Now this is bonded to the pH, which is just this. Okay, so I just shortened the pH for this aromatic here. Now you could kind of notice that Fischer esterification and transesterification, they're basically the same thing. The only difference is instead of using an alcohol and a carboxylic acid, we're actually using an alcohol and an ester itself. Okay, so let's go through the mechanism. So using the ester, the first thing that happens is pronation. Okay, so the lone pairs on the oxygen will go ahead and seek a proton, and we form water in solution. So we have an oxygen with 3 bonds that's positively charged, and we have the structure that looks like this. Now in the second step, our nucleophile comes in. So we have an OH, will come in and attack the carbon and form the alcohol there. Okay, so in that step, in this case, we come to a structure that looks like this. We have the alcohol, we still have this group here, and now we have this that's bonded to a hydrogen, and we're going to shorten the aromatic for pH. Okay, now oxygen 3 bonds plus 1 form a charge immediately. Now we formed the water in solution. Okay, we formed the water in solution in this step, as you can see. Okay, so the lone pairs will actually come in and take off the hydrogen and give the molecule a neutral state. So we come to a structure that looks like this. We have our pH. Okay, now let me ask you a question. What do you guys think will happen in the next step? Okay, in order for us to drive this reaction forward, the ether oxygen will actually get pronation. So we just formed acid in this step. So the ether oxygen will come in and seek a proton, okay, and form water in solution. And so we come to a structure that looks like this. We have our OH. Now we have an oxygen that has 3 bonds. That means it automatically has a plus charge. And we have our OPH. Okay. Now that this is positively charged, this makes it ethanol group, good leaving group. And so the oxygen, so the bond between the oxygen and nitrogen, the oxygen and the hydrogen on the alcohol group will actually come in and form a double bond. Okay, we're forming a double bond, it displaces ethanol. And so in that case, we come to a structure that looks like this. We have our ketone, we have our this carbonyl group that's now bonded to the oxygen that has the pH group, which is the benzene ring. Okay, so we come to a structure like this plus ethanol. So we come to a structure like this plus ethanol, plus again we have acid in solution. Okay, so this is a general mechanism of Fischer transesterification, and it's very much not it's very similar from in terms of Fischer esterification. So if I gave you this, okay, so if on a test you were given this and your acid products, if you use, what would be the products of this? Okay, so how I typically think of these is that I will draw my ester as it is and just draw whatever it's bonded to, the carbon chain. I'll draw the oxygen bonded to the additional carbon chain, and so the product for this will look something like this. Still have my ester, my oxygen, okay, and this is now bonded to a carbon, this carbon that has 2 more carbons on it. Okay, And so this would be the product for the reaction of this. Okay, so again, pretty not difficult, Fischer Transesterification. Now, I want to talk about the hydrolysis mechanism. So let's look at the hydrolysis. Yeah. So if on a test you're given this structure, okay, and you added an acid and heat, well, it will hydrolyze. And so if I'm looking at this, I know with Fischer Transesterification, I'm using in Fischer Transesterification, I'm actually using well, actually, this is not Fischer Transesterification. This is actually Fischer Esterification. Okay, so this would be Fischer Esterification. And so if I'm looking at this, I will actually get my carboxylic acid plus phenol. Okay, so this is Fischer Esterification, but I just want to show you the hydrolysis of the Fischer esterification. Okay, so if I'm looking at this, what will happen? Well, in the first step in the mechanism, like we said all the time, we throw carbonyl and acid, it will get pronation. So we'll seek a hydrogen and we get the pronation, and so we come to a structure that looks like this. Yeah, this has a plus charge, and we have that alcohol group here. Now that we formed water in solution, it will actually act as a nucleophile. So we'll come in and tap the carbon and form the alcohol in that group. And so with that, we get something that looks like this. We have our alcohol. We have our OPH, okay, which is a phenyl group benzene ring. And this is now bonded to an oxygen. It has two hydrogens. It has a plus charge. Okay. Now that we actually formed water in solution again, we'll come and take off one of these protons, act as a base, and give the oxygen the lone pair. Okay. So I'm trying to make sure you can see my arrow here. So give the oxygen the lone pair. Okay. And so the molecule will neutralize. So we have an OPH, and now we have an OH. Okay. Now what will happen in the next step? The ether oxygen will gain pronation. Yeah, that's our plus charge. And so the ether oxygen has two pairs of lone pairs on it. It will attack and form water. And so we come to a structure that looks like this. We're pH, oxygen, 3 bonds, plus charge, and we still have our alcohol group here. Okay, so what do you guys think will happen in the next step? What do you guys think will happen in the next step? Well, one of the oxygen will use its bond, okay, and come in and form a double bond and displace phenol as a leaving group. And so with that being said, we form the double bond to the carboxylic acid plus pH, which is this, and our oxygen that's bonded, and our alcohol group that's bonded to it. So that's the hydrolysis mechanism of Fischer esterification. Again, transesterification is a little bit more challenging to hydrolyze, but it's very similar. But transesterification and hydrolysis is not what is important. What is important is that you know how to hydrolyze Fischer esterification, and also to make Fischer esterification, and then also transesterification, which this video is mostly about, is basically the mechanism and the idea of using an actual ester and an alcohol to create the ester, which is what we call Fischer transesterification.